Welcome back to your channel, home study channel. In this part we are going to see the problems on the Spur gear. Already in the second part we have discussed the problem of the Spur gear, but that both videos are in the Hindi language. So there is a special requirement in the comments that why not you are going to make the videos in the English communication. So I decided to start making the videos on different kind of problems in the English language. So just start with the problem, as if anyone my friend is directly going to see this video. So my suggestion is that first of all go for the first video of this Spur gear. So you will clarify with all the formulas, all the required data to solve the different kind of problems from the Spur gear. So if once you clarify with the numericals, then clarify with the formulas, then it is just the putting the values and calculating the numbers. It is a very simple method. Once you got the what actually we have to take into considerations, what point we have to elaborate. So first of all go for the first video and then come to this video, then you will clarify with the numericals also. So let's see, problem is saying that it is required to design a Spur gear speed reducer for a compressor running at a 250 rpm driven by a 7.5 kilowatt. So this is a power here is given, then 1000 rpm is the speed. Electric motor, the center distance between the axis of the gear shafts should be exactly 250. So central distance between two shafts is nothing but the addition of the radius of both the gears on the lying on the shafts. Okay, keep in mind this factor will required further in calculations. So first of all, going to further, I want to tell that this video will take your time because this is one of the complicated problem, has a lot of calculations. So be patient. If you have patience, you will get the clarify once with this numerical. Then there is no matter what kind of problems in the exams, you will solve all type of problems. So this is one of the complicated problem, so it will take your time. So keep patience and keep seeing and go up to the end. Try to go up to the end, so you will clarify all the step-by-step numerical statements. Okay, so next statement is that the starting torque of the motor can be assumed as the 150% of the rated torque. So we have to calculate here actual torque, which is 1.5% of the rated torque. Okay, then the gears are made from the carbon steel 50 C4 SUT 700 Newton per meter square. Okay, the pressure angle is 20 degree. The factor of safety is 2. For preliminary design based on the use the velocity factor. Okay, as I explained in the formulas, there are two types of design, means a preliminary design and final stage design. So in preliminary design we taking account in the velocity factor. So step by step we are going to see how the problem is solved, but first of all we see what they are asked here to solve. First of all, design the gears and specify their dimensions. Then assume that the gear are manufactured to meet the requirements of grade 6 and calculate the dynamic load by using the Buckingham equations. Then third one, calculate the effective load. And fourth one, what is the actual factor of safety against the bending failure. Then fifth one, using the same factor of a safety against the pitting failure, specify suitable surface hardness for the gears. So we are going to step by step how to solve this problem. In any problem, first of all we have to write down a given data. What is given in our numerical, we have to put it in normal notations which we are used in the calculations. So here power is given, that is we mention here as a kW 7.5. Then CS is given to us, that is known as the velocity factor. CS is given here 1.5. Then speed of the pinion is given 1000 rpm. Speed of the gear is given as 250 rpm. Here is that mentioned that this is a 7.5 kilowatt of the power. 250 is the revolutions speed of the gear. keep in mind that pinion always speed and diameter of the gears are inversely proportional to each other. If it is pinion, it has more speed than the gear, because at it is smaller, it rotates more aggressively than the gear. So ultimately they are interchanging to each other. After that, ng, then center distance is given to us, that is 250 mm, and then a grade is given that will required in the further calculations, it is a 6. So first of all we have to calculate the module based on the beam strength. So for that we have to calculate the diameters of the pinion as well as the gear. So here center distance is given to us, then calculate the try to calculate the diameters from this equation. So as center distance equal to addition of the radius of the both gears, so dp plus dg divided by 2 is equal to 250. It is given to us. By equating this equation we get that dp plus dg is equal to 500. Then as I said that these are the inversely proportional to each other, diameter and the speed. So dg by dp is equal to np by ng. So as it is inversely proportional, so np is here, and as dg is on the numerator, the dg is at the denominator. Okay, so putting this 1000 upon 250 we get the 4. So by calculating this, dg is equal to 4 dphi. So putting this values in this first equation, we get that dp is equal to 100 mm and dg is equal to 400 mm. Obviously that diameter of pinion is smaller than the diameter of gear, and the ratio is as a 4, so it is a 4 times of the pinion. So the values are seems like that diameter of pinion is equal to 100 mm and diameter of gear is 400 mm. After that we have to calculate the velocity. So pi dp np upon 60 into 10 raised to cube. So why we are calculating the velocity on the basis of the pinion dimensions? Because this gear is manufactured with the same material. So when gear and pinion is manufactured with the same material, at that time the pinion is weaker than the gear. So we have to design on the basis of the pinion. So we are taking here account the dimensions of the pinion. So putting this value, the values are very simple, formulas very simple. As I explained there, we have to keep in mind simple formulas and just putting the values. Once you get the how the formulas are occur, then the numerical is nothing is there in the numerical. So step by step we are going to solve. 236 meter per second, the value of velocity is here. So when velocity is less than 10 meter per second, then we use the formula that 3 upon 3 plus v. So therefore we are using this formula and calculating this cv, that is a velocity factor. Then assuming this is a standard assumptions I have already discussed in the formula section also, that b by m is equal to always mention as the 10. Then we get that zp is equal to 20 and zp here is a zg is equal to 30. That is assuming these are the conditions which we have assumed here. So for ZP for 20 values there is a y is equal to 32. How it comes? It comes from this table that gives the values of the Lewis form factor y for a 20-degree full depth when evolute system, where for 20 it is a 0.320 and for 30 it is 0.358. So according to this we are taking the values into account, and we are going to take a mean value from that both, and by taking that values we are going to calculate y is equal to 0.34. Once we get the y here, then we get the b by m's formula, and sigma b is again here we have to calculate that according to us, that is given SUT is given to us and factor of safety also given to us. So SUT divided by factor of safety we get the sigma b. So SB is equal to m into b into sigma b into y. So we get the SB in the form of the module square. So putting these values which we have calculated here, 10 m into 700 upon 3 into 0.34, we get the SB is equal to 793.33 meter square module square. It is in the Newton. So again, using the formula of torque, as you know, the simple formula is equal to power is equal to 2 pi nt divided by 60. So putting that value here, T is equal to 16 to 10 raised to 6, because we are going to calculate the value of the torque in the Newton mm. So here 16 to 10 raised to 6 into power divided by 2 pi. Again here we are going to take the speed of the pinion. So putting these values, we get the torque of the that gear here. Then using the formula that Pt is equal to 2mt upon dp, a simple formula, or we can simply keep in mind that torque is equal to force into radius. So torque is equal to force into radius means radius is equal to dp by 2. So this is a force. So we are here we have to calculate the force. So we modify that formula like mt into 2 divided by dp. So simple formula like torque is equal to force into radius. This is a simple formula for here. So maintaining that, we calculate the pt, value of the pt. So value is 1432.39 Newton. After that we have to calculate the P effective. P effective is equal to CS upon CV into PT, which we have calculated here. So putting these both values, P effective, CS is given here 1.5 into this PT value divided by CV 0.3643. So after calculating this, we get the value of P effective here. So this is a basic formula for the SB. Here calculating for the SB, beam strength of the gear, that M into B into sigma B into Y. So again one formula, that is the P effective into factor of safety. So by using this formula, we can equate both the equations, like SB is here we get in the form of a module square, and here P effective into factor of safety. So we are going to equate these both equations. SB is equal to 7930.33 module square here. Then P effective we calculate here 5897.85, and into factor of safety in the problem it is given, that is 2. We are calculating, we are going to calculate the module. So we get the value of the module is like that 3.86. okay, so we have to prefer the value in the it is in the fraction now. So we are going to convert into integer value. So the first preference value of module is the 4 mm. So as we mentioned that width is always equal to 10 by m. So b by m is equal to 10. So equating that equation, we get the width of the gear is equal to 40 mm. So again we have to calculate the number of teeth and on the pinion and the gear. So as there is a formula for the module is equal to diameter of any gear divided by number of teeth on the gear. So equating that equations here, the number of teeth is equal to diameter upon module. So diameter are given to us, so 100 upon 4 is equal to 25 number of teeth on the pinion. Then diameter of gear is, we calculated that 400 divided by again module, that we get the 100. So here there are 25 teeth on the pinion and 100 teeth on the gear. So for 25 gear there is a Lewis factor that we have again take from the this chart. So for 25 number of teeth, the Lewis factor is the 0.340. So this is a given in the Bhandari. You can download this from my website also. I will talk about it in the later part. So going for the equations, so taking these values in account, now we have to calculate the beam strength. So we have calculated now M, we have with us B, then sigma B we already have, but now for the pinion of 25 teeth we have to calculate Y, that we calculate that we taken from the table. So putting this value, we are going to calculate the beam strength value. Then we get that 12693.33 Newton. So once we get the SB, then we are going to calculate the dynamic load by Buckingham equation for grade 6. As here given to we have to calculate Here given that assume the gears are manufactured to meet the requirements of the grade 6 and calculate the dynamic load by Buckingham equations. So we have to calculate a dynamic load by Buckingham equations. For that purpose we are going to as they mentioned specially that the machine is gear is manufactured with the grade 6. So we have to take a formula for the calculating the error, that is from the E is equal to 8 plus 0.635. This is a formula again we have taken from the tables which are given into the Bhandari. So we are not going to take any value in our directly from our mind. So all the values are given in the books and we are going to take these values from that particular books, and we have to refer that books because these are the principal values. If there are any changes in these values, the formula problem will be going to change. So for grade number 6 the formula is 8.00 plus 0.635, and same formula we have taken here. Then first of all we have to calculate phi, and formula for the phi is m plus 0.25 in root of dp. So we are calculating phi for the pinion here now. So we are taking the pinion diameter of the pinion. So after calculating the phi we get the value is something like that, and putting this value in this equation. So error in pinion is equal to 8 plus 0.63 into 5, and putting this value we get the 12.005 micrometer. Keep in mind when we calculate the error in any problem, the value that we calculated, it comes in the micrometer. It is not in the meter or mm also. So it is in a micrometer. Again for similar for the gear, then again formula for the phi is same, m plus 0.25 in root of dg. Value of dg here changed is 400 mm. Then putting this value here we get the 13.67 micrometer. It is a error in the gears. So adding both the years we get the error is equal to 25.765 micrometer. So now we have to convert it into mm. So into 10 raised to minus 3 we get the value of error in the form of the mm. So by now diffusion factors C is it is a standard value as I explained in the formula sections also. So this is one of the standard value that is 11400 Newton per mm square. The diffusion factor C. Then we have formula with us, PD is equal to 21V into C into E into B plus PT divided by 21V plus in root of C into E into B plus PT. So how to remember this formula I have explained in the formula section in part 1. So go to there and say again once, so you will get the idea to remember this formula. So now we have all the values with us from these equations. Now we have to just put that all the values and we have to calculate the PD. Once we calculated PD, then we are going to calculate the effective load. So effective load is equal to CS into PT plus PD because we are here using the Buckingham equations. If it is a beam strength equation, then P effective is equal to PD into PT into factor of safety. Okay, so here we have to keep in mind that P effective is equal to CS into PT plus PD. Okay, so we have with us CS is 1.5, PT we already calculated, then PD is here now calculated. Putting this value we are going to calculate with the P effective. Then we get the P effective value 8596.89 Newton. Okay, so now we have to calculate the actual factor of safety. This is why, because if actual factor of safety is less than the given factor of safety, then only the design is satisfactory. I have already explained you how it is works. So we have to calculate what is the actual value of the factor of safety after these calculations. So for calculating that SB is equal to again factor of safety into P effective. Just taking the P effective here, SB we calculated here already. So SB is equal to 129,693.33 divided by P effective that we calculated here, and we are calculating the factor of safety. So calculated factor of safety is 1.48. So given factor of safety is 2. So design is satisfactory and model M should be 4 mm, that we can be carry on. But if assuming this 4 mm, if it is not a particular case, but just assume that the value of factor of safety is more than 2, then the whole assumptions are get cancelled, and then we have to again assume the new values and again calculate all the values. But it is not happens in any problems, because the problems are compared with all the values and then given to students, because it problems are comes in maximum 8 to 10 marks, and there is no time for that number of calculations. So keep in mind that if the your factor of safety in the exam it is coming over given to the factor of safety, then there is something is mistake by you, so you have to again calculate all the values. Okay, then we are going to next step, that is we have to calculate the surface hardness for the gears, as they mentioned here. Here, using the same factor of safety against pitting failure, specify suitable surface of hardness. The surface of hardness means we have to calculate the BHN number, Brenner hardness number. So for that purpose, we have a formula with us that here is K, and K is replaced by BHN upon 100 into 10 raised to square. So using the wear strength formula, surface hardness for the gear, we have to first of all calculate the value of the Q is equal to 2 into Zg upon Zg plus Zp. So we have values with us, so we calculate the Q is equal to 1.6, and according to wear strength formula, we get that B into Q into dP into K, and again we write like in SB, as we write the P effective into factor of safety is equal to SB, and M into B into K is equal to SB. So here is also in wear strength B into Q into dP into K and is equal to P effective into factor of safety. So we have both the values here. P effective we have, then factor of safety already we have calculated here. As they mentioned that we have to use the same factor of safety which we have calculated here, so we are taking 1.48, but if there is not mentioned, then we have to calculate we have to take value of factor of safety here 2, but they specially mentioned there that we have to take that value of factor of safety that we have calculated 1.48. So we have taken that value of factor of safety here, and again then B is equal to, as we calculated 40 into Q earlier calculated here, then into diameter of pinion, that is 100 into that is the formula for K, 0.16 into BHN upon 100 raised to square. So putting these values, this is a game of your hands, that just put the values and calculate the value of BHN. So 352.49, this is a preserved value, is 360. If you don't know value, nearest value, how to take it, then just you put this value as it is, then you will get the marks in the examination. So finally we are going to mention the dimensions of the gear which we have calculated, like ZP is equal to 25, then the number of teeth on the gear, that 100, then module which we have taken, that is a 4 mm, then by using the formula module is equal to dp upon number of teeth, by using that we have calculated diameters also, then addendum is equal to module is equal to again module, so is 4 mm, then dedendum is 1.25 of the module, so we get 5 mm, then clearance 0.25 of module, it is a 1 mm. These are the standards. Okay, these are these values I am not taking from my mind. These are the in specified when we design the gear, these are the standards which we have to take, that we provided to us. So these are the standards, like addendum is always equal to module, dedendum is always 1.25 of the module, clearance is 0.25 of the module, then tooth thickness is 1.5708 of the module, then calculating this we get that 6.2832, then fillet radius 0.4 of the module is equal to 1.6 mm, and finally face width, that is B is equal to 40 mm. So these are this type of calculations we have to do. These are very simple ones. Once you clarify with the formulas, then calculation of any type of numerical, that doesn't matter. So finally I am concluding this with, if you really like this video and if you feel that is useful to you as well as your friend, then and then only you go to share this video with your friends, If you really like this, hit the like buttons. If you have any queries with this problem or anything you feel that I have missed here, so comment there, I will answerable to you. So if you really feel that you have liked this video, then like, share, comments, and please connected with us, and we will add more video as per your requirements. Thank you so much.